alright. I wouldn't keep saying alright. 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 If we take a look at this proof, this isn't necessarily a difficult one, but there's some stuff going on here. Again, with anything, it's like, let's mark off some stuff, see if it makes sense, and talk our way through it before we actually even set up statements and reasons. Because I think far too often kids are just like, statements, reasons, they make the T, they start with given has to be first, and then it's like, they just start putting stuff down without thinking about, hey, this has to make sense. Remember, there has to be a flow to the proof. So let's take a look at this. We've got AB, segment AB is parallel to segment DC. So again, mark those off congruent. Angle A is 40 degrees. Angle B is 70 degrees. What is angle ACE? So if I knew angle 1 and angle 2, could I not add them together to get angle ACE? And if I look at angle 1 and 2, can I use these parallel lines to relate them to either the 40 or the 70? Again, if I look at, I'm just going to do the, if I look at angle 1 with the parallel lines, don't I get the Z shape going right here? So there are alternate interior angles. If that's 40, angle 1 has to be 40. If I look at, if I look at angle B and angle 2, makes the F shape. They have to be congruent. Corresponding angles, 70 degrees, and guess what? If I add 40 and 70 together, guess what? It's 110 degrees. Now, that's all fine and dandy, but now I got to be able to put it into a proof, make sure it flows as I go down step by step. So let's set up statements, reasons. At least now I know what do I got to do. I got to find angle 1 and 2 to get them equal to those and then add them together. Now in this case, we're going to start off with AB parallel to DC. And I'm just going to go ahead and put everything down here. Angle A equals 40 degrees. Angle B equals 70 degrees. So right off the bat, I got to be like, all right, let's angle A and B are 40 and 70. Let's make a relationship between those angles and angle 1 and 2. Angle A and angle 1 we said were equal. Alternate interior angles. It makes that Z shape. So parallel lines imply alternate interior angles congruent. For angle 2, it made that F shape. F shape is corresponding angle. So I can say, hey, angle B equals angle 2. Parallel implies corresponding angles congruent. Now I still haven't involved angle ACE yet, right? So I'd be like, all right, well what is angle ACE made up of? It's made up of these two adjacent angles added together, right? Angle 1 plus angle 2 gives me the big angle that makes angle ACE. What lets me say that a big angle is equal to the sum of its parts, basically, the sum of its adjacent angles. Non-overlapping angles. Well, that's the angle addition postulate. It lets me add some angles together to get the big angle that they make. So this is the angle addition postulate. Now, what can I substitute in place of angle 1 and in place of angle 2? Angle A and angle B, right? It's like that's going there, that's going there. So angle ACE is equal to angle A plus angle B. Substitution. Remember, substitution is a one-shot deal. And I'm not saying this is the only way to do this proof, but this is working, at least the way we have it set up. Now, what is angle A equal to? 40. What's angle B equal to? 70. I can do substitution again. Some of you might be like, can I just have substitutions all in one step? Well, it's a process and we're substituting again into the same equation. ACE angle ACE is equal to 40 plus 70, both of those are degrees. Now if we're simplifying an expression, what's 40 and 70 give me? Angle ACE equals 110 degrees. Bam, we are done. That's, again, could I have had, could I have substituted up here and said angle 1 equals 40, angle 2 equals 70, sure, and then substituted down here? Take your pick. but to me, this proof sort of makes sense as we go through it and it flows. We'll take a look at one more, which was proving lines parallel, and this will involve some supplementary angles. So I want to use one of those specialty theorems again. So let me erase this. We'll just tag this in at the end rather than stop, record, and start over again. We'll just have it all in one shot. So in this case, let's put up lines, line this way, 1, 2, 3, 4, given angle 1 supplementary to angle 4, angle 1 supplementary to angle 4, prove A parallel to B. So again, as we look to prove lines parallel, we have to throw in, do I have corresponding angles? Do I have same side interior angles? Do I have alternate interior angles? Well, this should be like, again, like the sirens are going off in my head right now. If I know two angles are supplementary, maybe I want to use same side interior angles, or maybe I want to use one of those specialty theorems that involve supplementary angles. So in this case, I'd be like, do I have the C shape? Well, if I made the C shape right here, it's angle 3 with nothing that's labeled. If I made the C shape this way, it's angle 2 with nothing labeled. So I don't want to use parallel line or same side interior angles supplementary to get parallel lines. But what else do we have? Well, I could make an F, could I not? That one didn't come out so well. I'm using the wrong blue marker. Let's try the other blue marker. So if I look at angle 1 and angle 3, those are a pair of corresponding angles. If I could show that 1 equals 3, I could then say A is parallel to B. Now, how am I going to do that? Well, let's take a look at this. Statements, reasons. We start off with the given, angle 1 supplementary to angle 4. Now again, I said if I didn't want to use same side interior angles, I wanted to try and use that supplements of congruent angles are congruent. Do I have any other supplementary angles in this figure? Well, 2 and 3 are supplementary. That's not going to help me with this. 3 and 4, there's a 4 there, are supplementary. Now how do I know angle 3 is supplementary to angle 4? So you might be looking at it and say, well, I don't know. How do I know they're supplementary? That's a linear pair. That was one of the things that we said would give us supplementary angles. So we could say linear pair, two adjacent angles whose non-common side form opposite rays imply supplementary angles. Now I have two angles that are supplements of the same angle. So I can use that supplements of congruent angles congruent to say, hey, if I have two angles that are supplements of the same angle, they have to be equal to each other. Angle 1 equals angle 3 by that theorem. Now, what kind of angles are 1 and 3? Corresponding makes the F, right? If they're corresponding and they're equal, I can say, hey, that was a postulate. Corresponding angles congruent imply parallel lines, and that's going to give me A parallel to B. And we're done. So we probably need a Lego joke right now, so I'll let the Lego joke take us out. Thanks for watching.
Hello, my name is Kira and this is Caitlin. We are from Team Technobricks and welcome to the Techno Kitchen. Caitlin, what bird is with you at every meal?
I don't know. What bird is with you at every meal?
A swallow.